All right, good morning. Welcome to Intro to Statistics. We are in the midst of section 6.2, which is binomial distributions. And I thought I'd start with a problem that looked like, hey, I've asked this one before on a quiz. So just a heads up, this is the kind of question you're looking at. So this is at Denver International Airport. 70% of recent flights have arrived on time. A sample of 11 flights is studied. Round the probabilities to 4 decimal places. That's typically your the case is to round to 4 decimal places. Okay, so questions are, is it binomial? Or how do we know this is binomial? Okay, I would love to be able to, there we go, move this down a little bit. So is it binomial? Well, we're going to do a couple of things. We're going to say, hey, we picked 11 flights. Okay, we have two outcomes. Is it on time or not? But it's only 2 minutes late. Doesn't matter. It's not on time. Okay, that's all the criteria is. Is it on time or not? Okay, so we're not worried about how much on time it is. If it's 12 hours late, there's probably a different category it goes into. But if it's 5 minutes late, if it's 2 minutes late, it's like it's not on time. Okay, or whatever criteria they use to judge that, that's what we're going to do that. And they said we're gonna take this p to be a 0.70. This is a probability of success that it's on time, and we're going to assume that they didn't pick all of these in one day. Okay, I think I've looked at previous formats of this problem where they made sure to like pick like 11 random days or something like that, or 11 random flights on different days so that they would be dependent on each other. Because one flight's going to be late, chances are there's a weather thing. It's going to interfere with all of them. So yeah, we're going to assume that. Okay, so the probability is not changing. We have two options. We have a set. We picked 11 of these, and they want to know. Okay, find the probability that all 11 of these flights were on time. Okay, so we have n is equal to 11, p is equal to 0.70, and then for part A here, the x value is they want to know if all 11 are on time. Okay, so we're going to come over here to our this. We're going to come over here to our calculator. We're going to hit second function, distribution. We're going to go all the way down to where it says binom. Now, you have a choice, CDF or PDF. A PDF means they want x equals exactly a number. Okay, in this case, 11. CDF, okay, is what they call its cumulative distribution function. Okay, cumulative distribution function. Okay, PDF is a probability density function. Okay, they want cumulative density function. Cumulative density function. Okay, and this automatically says we're going to go from x equals 0, and we're going to add up x equals 1 plus x equals 2 plus x equals 3. We want the probabilities for all of these up until we get to the answer we actually want. Okay, the probability density function, okay, that's for just that number. So the PDF is, I always think about this as for the particular number that they want. The PDF is the particular x. The cumulative is the collection of x's. Okay, so whatever helps you kind of keep those straight, okay, whatever you're going to associate those letters with, please do that. I use particular number and then collection of numbers for mine, but the collection is going to go from x equals 0 up until the one that you want. The PDF is the particular one that you actually want to deal with. Okay, so we're going to go ahead and look at this probability. They want all 11 flights for a time. They want so 11 out of 11. So we're going to PDF. So we enter, and remember, it's always going to be it's going to be NPX. That is the series of arrangements that you give the arguments to the function. Okay, so we have 11 flights. Okay, we want 0.7. Okay, if you don't give it a decimal here, we'll get mad at you. Okay, so 0.7, comma, and then we want all 11 out of 11 to be on time. And this will do all the calculations for us. Okay, so we ended up with the 4 decimal place 0, 1, 9, This 7 looks like it's going to round up to an 8 here, so we're going to say 0.0198. Okay, so 0.0197 is going to go to an 8, so that's what I'm going to type in here. We're going to say 0.0198. All right, and we'll check. Say hooray. All right. So they want, what's the probability that exactly 9 of the flights were on time? Well, this is pretty much the same problem we just did, right? We want binomial PDF because they want the particular value. We want exactly 9 of them. So we're gonna, and this is, by the way, if I have to show work, we just do things in Alex, so I let Alex handle that. But if I was going to be collecting your work, this is what I would want to see. I want to see the sequence of keys that you typed in your calculator. So we're going to have 11 possibilities. 0.70 is the probability. You don't have to, you can see 0.7, it'll be okay. You can put a fraction in here, it'll still work. As long as it's less than 1, it'll be fine. Okay, and we want 9 because that's our x value that we're looking for. Okay, so we're going to go ahead and type that in. So we want binomial, so second function distribution, binomial. We're going to pick the PDF because we want the particular function value for 9. We have 11 flights in total. There's a 70% chance that they're going to be on time. And then how many do we want? We want 9 of them exactly. Precisely, that probably that 9 of them have done this. Okay, so double checking. Exactly 9 flights were on time. Hit enter. We got 0.11975. The 3 decimal places, I think this 97, so we'll say 0.199. The 7 is going to turn into an 8. So it's going to be 0.1998. Okay. 0.998. Okay, and Alex is very, very picky about the kind of numbers it puts in and very picky about your round off. Okay, I've asked before because I've had students who like, this is my first math class and this is my last math class. I was never very good at this, and I can appreciate that. Not everybody has to do, have every talent. Oh, that's fine. But they round in different spots, and we're to people at the good people at Alex, and they're like, "Do we, change this like where it rounds off?" I'm like, nope, it goes where it goes. And they gave me probably an email about how accuracy is important. Okay. Like, yes, it is, but I got students who round off in random places. So because we used to do this all by hand rather than a calculator, so it was a little different for people. Okay, so yes, they when they say 4 decimal place, they mean the exact number that comes out of that calculator. Okay, so part C, this is going to be a little bit more of a problem. Okay, and let me show you how we're going to set this thing up. They want 9 or more flights. Okay, so we want 9. What are 9 or more? 9 or more. What numbers are 9 or more? 9, 10, or 11. So we could do this. We could say binomial PDF and then do 9 or 11. Probability of success is 0.7, and then do 9 to get an answer. Do the same thing. 9.7, 10. Binomial PDF. PDF, that's complicated, right? Get an answer. And then binomial PDF and get, so this is 10. Binomial PDF, we have 11.7, and we already have 11. Notice we already have 11. So back when I used to teach this face-to-face, this would be a pretty common problem that I would ask because I already asked you for the first one. So you have to do is do 2 more, add all of these up, and that's going to be the answer we're going to give. Okay, and that's a very appropriate way to do this problem. Okay, I'm going to do it a slightly different way because I'm going to do it the clever way rather than this way. And there's nothing wrong with this. Okay, the calculator is doing the heavy lifting. Okay, we just have to add up 3 numbers. That's not the worst thing in the world. Okay? So don't be. I know it's a lot of calculations. It was worse when we did it all by hand. Now the calculator does the heavy lifting, so we just add all these numbers up. Okay, actually, I think we did. It's for 9. So we have 9, 10, and 11. Okay, we've already done 2 of these. You only have to have 1 more number to calculate. We're done. Okay, so you could type in 0.1998 here. And it was all 11. All 11 was back up here was 0.198. 0.0198. goes for 4 decimal places. It's for 11. So all we're going to have to do is calculate binomial. So we're going to go second function, distributions. We're going to go to binomial PDF because we just want, in this case, we want 10. That's the one that's missing. Okay, so we're going to go to, where is binomial? Nope, not this one. We are here. We want binomial PDF, the particular value. We're going to type this in. We're going to have n is 11. That didn't change. 0.7 is our probability of success. Right? And we want to see what happens. What's the probability for 10 of these to show up on time? Okay, 10 out of the 11 to show up on time. Okay, we're going to say 0.0932. Okay, so this was 0.0932. We're just going to add all of these up. Okay, that's all we're going to do here. So I'll just type that off to the side here. Okay, so that's why I wrote it down, because we have 0.0191 plus 0.0932 plus 0.1998. Okay, and then we got 0.3121. All right, so that was the probability for, let me go back and check our Alex thing here. They want the probability that 9 or more of them were on time. Okay, 9 or more. Okay, so let me show you this way. So if I go through and I do the CDF, okay, we would figure out the probability for x equals 1, 2, 3, dot, 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 all the way up to 8 of them. This will be, or actually 0, up to 8, sorry. 0, 1, 2, 3, don't forget the 0, 1, dot, 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 all the way up to 8. Okay. The whole probability, like for all 11, this has got to add up to 1. So if I say 1 minus the binomial CDF, okay, that's going to go from, we want n is 11, p is 7, and our x, we're going to go up to 8. What is that going to leave left? What did we not calculate with up to 8? We have 9, 10, or 11. Okay, so we're going to say 1 minus binomial CDF. That's going to give us the values for 9 plus 10 plus 11. Let's see if that works. Okay, so we're going to say distribution. Okay, we're going to go into where it says binomial CDF. Okay, for cumulative. Okay, the collection. We want the 0 through 8. Okay, and we're going to type in, we're going to say 11. Okay, we want 0.7. Okay, and then the last one is going to be up to 8. Okay, and then we'll see what happens for that. Okay, and 0.6873. 6873. So what I'm going to do is I'm going to say 1 minus, right? Because that's what we really wanted here is 1 minus what this answer was. So 1 minus this answer. Okay, and I got 0.3127. That's pretty close. Okay, I probably rounded in a different spot. I'm going to think that this 0.3127 is probably a more accurate answer because I have a feeling I messed up one of my numbers here. Okay, so again, in a face-to-face class, if I see this, I'm just going to mark it right. But if you do it this way, I'm going to mark it right as well. But Alex is going to be pickier. So you need to be careful when you do this. Okay, so because I had to depend on myself for writing down these numbers correctly, entering them back into the calculator correctly, there's a lot of places where I can make a small mistake and not get the right thing to come out. So I'm going to trust the one-step method rather than the fact that I did this in 3 steps. And we're going to pick the 0.30 or 0.3127 here. So the answer I'm going to give it is 0.3127. Okay, technically both are correct, but we have to worry about round off. So 3127 here, or where we rounded for the other 2. So I'm just going to try to be safe and make sure that we've done it right here. Okay, check. Right. Okay. And it wouldn't be unusual for 10 or more flights to be caught on time. Again, I think we already have those. Okay, and since they want 10 or more, okay, anytime it's unusual, it is 0.05. That is the cutoff for 0.05 or for unusual. Okay, so let's go check that. Okay, so we want We go up a little bit and we'll say, okay, what's the probability for 10 of them? Did we check? Did we do that one? I think we have. There's 0.009 for 10. And then for 11, that was 0.01. So it's close. Okay, we want 0.05. This is going to be a little bit bigger than 0.05. So no, it would not be unusual for 9 or 10 flights to be on time. I think there's a 0.0 here. I think this was too much. Okay, so I think 11 was this one. It was 0.01. Okay, it's not the first one we did. There it is. Ah, there it is. This is one. Okay, but for 10 flights, remember this was 0.09. Okay, I'm going to double check it for 0.09. So distribution, binomial, PDF. Because I just want to check for 10. Okay, binomial, PDF. Okay, we want 11. This used to be a lot worse when we had to solve by hand. Oops, I want 11 flights. That's my n, comma 0.7. Sorry, probability of success that they're on time, and then we want x to the 10. Okay, so make sure I'm looking at that right. Looks kind of like I'm looking at that. So that was 0.09. That's bigger than 0.05 by itself. Okay, so no, it would not be unusual. It would not be unusual for 10 or more flights, because for 10 flights, it's going to be 0.09. If we add the 11th flight, that's going to be about 10%-ish, so that's bigger than nickel. The dime is bigger than nickel, since the probability is, oh, they actually asked me to do it. Oh, good Lord. Okay, so we have plus, what's this? We'll do it like this, plus, and I'm going to say second function distribution. So this was for 10, second function distribution. We're going to say binomial PDF. So we're just going to save a step of me having to write it down. Okay, we want 11.7, and we want all 11 flights. I know I already have it, but I'm not going to trust myself to transcribe those numbers. Okay, enter. We got 0.11299, so I'm going to say 0.113. Okay, so this was 0.113, and that's bigger than, that's bigger than 5%. Okay, so that's what they want us to do. We'll check. Hooray, we can move on with our lives to the next one. This is a very, very typical problem that I would give. Okay, so if you're looking for like which ones you want to practice, something like number 5, actually, generally the middle of the pack of the problems is generally the ones you want to pick. I try not to pick the first couple because they tend, sometimes they're a little weird, and the last couple tend to ask you to go on to the next step. So fair quiz questions are stuff in the middle, okay, because those tend to be like the canonical type of problem. So I thank you for tuning in. This is problem number 5. Again, if you want to practice one of these, this is perfect. I wouldn't feel bad about asking you this question at all. Okay, thank you, and I'll see you in the next video.